Hello everyone, hope you are doing well. In this video we're going to talk about the mean value theorem. So let's just write it. Mean value theorem. So what does the mean value theorem tell us? Suppose that we have a function f that is continuous on the interval, closed interval a to b, and differentiable on the open interval a to b. Then there is at least one point C such that f prime C is equal to f of b minus f of a divided by b minus a. Now, what does it geometrically means? Let's just say we go up from here. Geometrically is basically here, if we draw it, suppose we have a function, suppose the function is something like that. This is a and this is b, and the corresponding is a function y equal f of x, and the function value at this point is f of a, and this is our f of b. So the mean value theorem is basically telling us that there is a point C here such that f prime C is equal to f of b minus f of a divided by b minus a. F prime C, this is our slope of the tangent line, which is basically here. F prime C is something like that. So f prime C, the slope of the tangent line, and this is our slope of the secant line, which is our right hand side, f of b minus f of a divided by b minus a. So the mean value theorem says that the slope of the tangent line is equal to the slope of the, is parallel to the slope of the secant line. This is our mean value theorem. For example, suppose that we have a function f of x equal 1 by 4 x cubed plus 1, on the interval 0 to 2. Now we have to see that does it satisfy our mean value theorem or not. Thus first we have to do a derivative f prime of x is equal to 1 by 4 times 3x square. Now to apply the mean value theorem, first we have to check that is this function continuous and differentiable on the interval. Here the f of x equal to 1 by 4x cubed plus 1. This is a cubic polynomial function, so of course it is continuous and it is differentiable because it doesn't have any, this graph does not have any breaks, jumps or any kind of holes, so it is continuous. And we also know that polynomial functions are always continuous and it is differentiable, doesn't have any sharp corners or vertical tangency, so it is differentiable and continuous. Now the first condition is satisfied, so there is at least a point C for which our slope of the tangent line is equal to our slope of the secant line. So f prime of C here is 1 by 4 times 3c square. Here A is our 0, which is our initial point, and B is 2, this terminal point of the interval. So if we calculate f of A, which is f of 0, we get 1 by 4 times 0 equal to 1, and f of 2 here is 2 cubed by 4 plus 1, which is 8 divided by 4, 2 plus 1, which is 3. Now we calculate f of 2 minus f of 0 divided by 2 minus 0, we get 3 minus 1 divided by 2, so basically we get 1. Now we apply the mean value theorem, so f prime is C equal to 3c square by 4 equal to our this value, which is 1. Now we solve this, we get 3c square equal to 4, c square is equal to 4 divided by 3. From there we get c equal to plus minus 2 divided by root over 3. So we get two values of c, which is one is 2 by root over 3 and the other one is minus 2 by root over 3. Now which c value is correct here for our math? Here we see that the interval given here is 0 to 2. So minus 2 by root 3 is outside of that interval. So the only c that we get from here is c equal to 2 by root over 3. So this is our c value that we get, for which our slope of the tangent line is equal to the slope of the secant line, and both are parallel. Thank you for watching this video. I'll see you in the next video. Take care. Bye. And don't forget to subscribe. Thank you.